Hello once again. Welcome back to our look at analytic trigonometry. We are doing pretty well, making pretty good headway here. We have now one last major issue with analytic trigonometry, and we've been wrestling with it for a while now. And that issue is solving general equations. We have identities, we have formulas. We can use those to prove new identities, show things are always true. We've looked at now basic equations, using basic problem-solving skills and applying that in the world of trigonometry. So now the time has come to bring everything together. You see, solving trigonometric equations is more than just doing algebra. It's more than just doing inverse trigonometry. It's doing everything that we can possibly do to find out when equations are true and when they are false. So let's just get right to it. There are things that have to be addressed. First things first, what are you looking for? What are you trying to find? So, spoilers ahead, right? Finding all solutions to this equation, 4 tangent 4 theta equal to 4 root 3. What do we need to find? That is a question that we have to ask ourselves and then answer. You see, I need theta so that tangent of 4 theta, when multiplied by 4, gives me 4 root 3. Hopefully that happens, and the only way to know for sure is to find theta using algebra techniques. Now, you might see the 4 theta and you say, oh, I can do the double angle formula, get that into tangent of 2 theta. Do it again for all my tangent 2 theta folk and get tangent theta. And that's true. You could do that, but that will get us further away from what we want. What we want is theta. And the best way to get to theta is to get to tangent of 4 theta, and then to get to 4 theta, and then to get to theta. You see, one of the more complicated things about what we're doing here is trying to overthink it, trying to overcomplicate things. We need to reach for the simplest solution first. And the simplest solution here is to divide by 4, undo tangent with arctangent, and find that a specific solution is going to be 4 theta plus pi thirds. Of course, the general solutions, right, all solutions is going to be 4 theta equaling pi thirds plus k pi. So we got that. And going from there, right, recognizing that all of this is 4 times what I want, I can get what I want simply by dividing everything by 4. Dividing this equation by 4 gives me theta is equal to pi twelfths plus k pi over 4. And that will get us what we want. Additionally, I'm hoping that we'll slowly, as we progress with this, start to buy more and more into using this k pi or k pi over 2 or k pi over 4 kind of notation. Because if you were to write this out in words, if you were to write out what this simple equation says in words, you would have to say, oh, this is everything coterminal with 15 degrees, because that's pi over 12. Pi over 12 is 15 degrees. And you'd have to add 45 degrees to that over and over and over and over again until you make it all the way around the unit circle. So this simple equation, pi over 12 plus k pi over 4, is equivalent to saying everything coterminal with 15 degrees, 60 degrees, 105 degrees, 150 degrees, 195 degrees, 240 degrees, 285 degrees, 330 degrees. But the fact remains, you can say this. You can say that. The fact remains you could do double angle formulas for tangent. You don't have to. You could say all this stuff. You don't have to. You just have to convey what you want to convey in a way that can be understood. And that is the first thing I want us to keep in mind here. If you don't have to do things, if you don't have to do formulas or identities, then don't. Just work directly or as directly as you can. Next idea. If you do have to use substitution, or you have to use some identity, use the nicest ones you can as possible. Or in other words, right, they're all nice. Use the ones you are most comfortable using. So for instance, suppose I wanted to solve the equation 2 cosine squared theta plus sine of theta equal to 1. Well, remember, if I had something like this, 2 sine squared theta plus sine theta equal to 1, that's something we could probably handle. That's something that might call for a quadratic formula, right? This would be 2u squared plus u minus 1 equal to 0. So maybe the quadratic formula. Maybe it factors, maybe it doesn't. Maybe we could complete the square, maybe we couldn't. But if we had something like sine squared and a sine and a number, we could be able to handle it. Well, let's do that. Let's substitute something in for cosine squared to make everything left look exactly like, well, not exactly, but similar to this, right? Something with some coefficient onto sine squared theta, some coefficient onto sine of theta, and some number. So we can turn cosine squared theta into 1 minus sine squared theta. So let's do that. 1 minus sine squared theta goes in for cosine squared theta. And doing a little bit of factoring, a little bit of maneuvering, you distribute this 2, you bring this 1 over to be 1 here after it subtracts out of the 2, and do a little bit of factoring, and you come up with these solutions here. So I'll give you a second to look over this. Right, because we factor this out, we're asking ourselves what multiplies to negative 2 adds to 1. And that would be negative 1, positive 2. And then we have solutions whenever sine of theta is 1, and solutions whenever sine of theta is negative 1/2. Sine of theta equals to 1 only at one place, at pi over 2. Sine of theta is equal to negative 1/2 in two places, 7 pi over 6 and 11 pi over 6. And so everything coterminal with that is all of the solutions. And that's a good one. That's a pretty good one, I would say. And here is a good stopping place, I think. What we're going to do with these next few videos is just give us a few quick examples. Pretty much everything for the rest of this section is just example after example of ways to use algebra and trigonometry together to get at solutions to equations. And that's a big enough ask right now. That's a big enough ask. So we'll stop right here. We've got now not using substitutions when we can get away with not using any substitutions. We've got using the Pythagorean identities when we can do that to help us out. And there's other substitutions as well, other approaches as well. And we'll get into those here in a bit. So I will see you in the next video. We'll have a few more examples, and then we'll get going.